Hello, I want to give you guys some examples about how to use the zero product property to solve quadratic equations. So if you're in my class, this should be the title on your page of notes. So I want you to remember that if I have two numbers and they're multiplied together and I don't know anything else about them, but I know that their product is zero, then one of them has to be zero. So remember, if A times B equals 0, then either A equals 0 or B equals 0. That's the zero product property, and we're going to use that to solve quadratic equations. Up till now, you guys have solved a lot of linear equations. Now we're going to be solving equations that have an x squared in them. Example 1. Suppose I have this equation. It has to have an equal sign with it and be equal to something to be an equation. Otherwise, if it was just this, it would just be an expression. So there's my equation. It's equal to 0. So I want to use the zero product property. But that's writing the area as a sum. That's not writing it as a product. So the first step is going to be to factor it. I'm looking for factors of 4 that when I subtract them, I get 3, positive 3. Well, that would have to be 4 and a negative 1. This was a minus, so that means that the signs have to be different. And this was a plus, so that means the larger factor is going to be positive, and I'm going to subtract the smaller factor. So I now have a product that equals 0, just like I had up here. So my next step is going to be setting each of those factors equal to 0 and then solving for x. So either x plus 4 equals 0 or x minus 1 equals 0. To solve this, I do the inverse operation. I do the opposite of adding 4. I subtract 4 from both sides, and I get that x equals. And to solve this, I'm going to do the same thinking. I'm going to do the inverse operation. I'm going to add 1 to both sides. So the solutions to this equation here are x equals negative 4 and x equals positive 1. Let's try another one. Example 2. Again, we're going to have to factor it. This is why you really wanted to know your factoring last chapter. I'm looking for factors of 8 that add up to 6. So you could make a list of your factors of 8, 8 and 1, 4 and 2, and 4 plus 2 works. So that's going to be the pair that I'm going to use. This is positive, so the signs are the same, and this is positive, so the signs are both positive. And just like in the example above it, I'm going to say either this factor equals 0 or that factor equals 0. And then I'm going to solve each of those one-step equations. We're going to keep doing more examples. Example 3. You might notice I skip a line at least between examples to make for neater notes. Now we need to factor something that has a number other than 1 at the front. And this is where I've seen many of you struggle. I suspect that some of you have been making use of resources other than your own notes. So what we did in our notes to solve these problems is we started out by making the X box. And I know that the terms in the front are going to multiply to give me 5x squared. And in the back, they're going to give me 6. And I need to split up 31x between these two boxes in order to finish my factoring. And so I taught you the X game trick, where you are looking for factors of something that add up to something. Well, in this case, I'm looking for factors of the product of 5 and 6, which is 30, that add up to 31. Well, pretty obviously, the factors of 30 that add up to 31 are going to be the factors 30 and 1. So that means I'll put a 30x here and a 1x there. I could swap them, but those are going to be the two things that go in those corners. In the next stage, I'm going to be factoring each row. Well, in the bottom row, I can tell 6 goes into both of those. And in the top row, no number but x, so I could have just an x pulled out of those. And then for this column, I can pull out a 5x from both of those terms. And I could pull, well, there's nothing I can pull out of there, so we'll just say 1. And it's a positive 1, just like this was a positive 6. So my factored form becomes 5x plus 1 times x plus 6. This was the kind of scratch work I was hoping to see on your tests, because that would have told me that you were doing it the way we had been doing it in class. But I'm not done. That factored form is equal to 0. And now I'm going to do exactly what I did in examples 1 and 2. I'm going to set each factor equal to 0, and then I'm going to solve it. Now, I'm confident that you guys can all solve this one on the right. The inverse of adding 6 is subtracting 6. So you add a negative 6 to both sides, and you would get x equals negative 6. Here, I want to get that x alone. My first step is going to be to get rid of the plus 1. So I'm going to add negative 1 to both sides. It'll cancel out on the left, and I'll get 5x equals negative 1. I still want to get that x all the way alone. The inverse of multiplying is dividing. So really, you're multiplying by the reciprocal, 1/5. I sometimes get lazy and just say you divide by 5. So if you divide both sides by 5, these 5's cancel out, and this side equals negative 1/5. So those are your answers to this equation. If I were to plug these numbers, either one, back in for x into the equation above, if I did it all the way and did order of operations correctly, the answer I would get would be a 0. Similarly, back in example 2, if I plugged in either one of these answers for the x, what would come out would be a 0. Now I've got 2 more examples, but I'm near the bottom of my page. So I'm going to go ahead and flip my paper over. That was example 3. Let's do example 4. Now I'm going to try to do this one the way that I think some of you have kind of been trying to understand from the internet, rather than using the notes I gave you on pages 16 and 17. So it still starts with the x game. So I'm still looking for factors of the product of 3 and 10. So factors of 30, which I got by multiplying 3 times 10, that add up to negative 11. Now, I'll make a nice list of all the factors of 30 that I have. There's 1 and 30. That won't work. There's 2 and 15. That won't give me negative 11 either. There's 3 and 10. I could get 13 out of that, but no. 4 doesn't go into 30. There's 5 and 6. Oh, 5 and 6 add up to 11. And since they have to multiply to be a positive 30, but add up to a negative 11, that means it must be negative 5 and negative 6. So that tells me that negative 5 and negative 6 are going to be the factors that I want to use. Now, that means I'm going to break up the negative 11x into negative 5x and negative 6x. So some of you are just writing this next line. And then you're doing your factoring by grouping. I'm telling you that I want to see this work because this tells me you understand how you got these two numbers. Now you can look at the first two terms and say, I could take an x out of those. And you can look at the second two terms and you could say, I could take a negative 2 out of those. And now I've got the 3x minus 5 with both of them, so I essentially factor that out. And what I'm left with is x minus 2. So if you're just writing this, and then this, and then this, without understanding where it came from, I hope you understand a little bit better and that you start to include this work. But really, this step that we're doing here, probably easier for most of you, because I know who you had for Math 1, probably easier for you to use this method. But coming back to this problem, now it's just breaking it up into two separate linear equations that we solve the way we've been solving for years. Either 3x minus 5 equals 0, I get that here, or x minus 2 equals 0. Let's solve the one on the right because it's easier. The opposite of subtracting 2 is adding 2. If I add 2 to both sides, I'll get that x equals 2. 2 minus 2 would be 0. On this side, it's more steps. I want to get this x term alone. I'm going to start by adding 5 to both sides. Because 0 plus 5 is 5, and negative 5 plus 5 would just go away. And then I want to do the opposite of multiplying by 3, which is really multiplying by the reciprocal 1/3. But I'm lazy, so I'm going to just say I'm dividing by 3. So I'm going to divide both sides by 3, and I get x equals 5 over 3. So my answers are x equals 5 over 3 or x equals 2. If I was going to write an answer and put a box around it, that's what I would put. We'll do one more example. Maybe you can guide me through this more on your own. Now I have a problem because this is not equal to 0. But I want to use that zero product property because it just helped me find the answer to quadratic equations. So I need to rearrange this so that it's all equal to 0 somehow. So what I'm going to have to do is I got to get rid of this on the right-hand side so that that's a 0. In order to do that, I'm going to have to do the inverse. I'm going to have to add 55 to both sides so that on the right-hand side, I have a 0 because those are additive inverses. Now I have an equation that looks like the ones we've been doing. And luckily, the leading coefficient is a 1, so it's not one of those harder problems, but I'm still thinking X game. I'm looking for factors of 55 that add up to negative 16. Well, let's see, there's 1 and 55. Nope, it's not even. 3 doesn't go into it. If 2 doesn't go into it, 4 is not going to go into it, but 5 goes into it. 5 and 11. 5 and 11 work. Negative 5 and negative 11 would multiply to give me 55, and they would add up to negative 16. So those are going to be the numbers that I use. So that means that when I factor it, I'm going to have x minus 5x and x minus 5 and x minus 11. Sorry about that. Those are the factors of this trinomial. So now I'm going to solve those ones. Either x minus 5 equals 0 or x minus 11 equals 0. And I can solve each of those. Now I can leave you with one last more challenging question. Suppose, and I'll give you one that's like this a little bit. Suppose, and this is just extra for experts. Suppose I have this equation. That's not even a quadratic. That leading exponent is a 3. So if I graph it, it's not going to be a parabola like the other ones were. It's going to have more curves. It's a cubic. We call it a cubic when it has the highest exponent. That's a 3. So the trick for this one is to recognize that I can take the greatest common factor out of every single term. I can take an x out of everything. That's going to be a 1 now. And now it's just the problem that was above it, so I can finish factoring it. So now when I use the zero product property, I've got 3 things multiplied together, so I'm going to have 3 answers. X itself could be 0, or x could be 5, or x could be 11. So I hope this is giving you a hint how you're going to be solving polynomials with higher degrees eventually. But right now, our main focus is on solving quadratics.